Okay.
Hello and welcome to WasmCloud's community call for April 22nd. We're kicking off with a demo from Colin Murphy, who's been doing stuff with WebGPU. Colin?
Hi, everybody. So I hope to make up for my lack of preparation with enthusiasm. So um, this is something I've been chasing for a while, and something I mean, and also like um, it's mostly not my work, right? I mean, I think you can only say it's really my work for the last 48 hours. So but it's definitely something, and Mendy Berger's done all of this, or at least it seemed, apparently he's done everything. I'm sure there's other people too, but so uh, I've been kind of chasing this issue, this kind of problem with WebAssembly, which is that for really compute sensitive tasks, you really do get a performance hit. Um, and I gave a talk, I think it was maybe 3 or 4 years ago, about SIMD. And I was doing fast image resize. I did some work on fast image resize for WebAssembly, the Rust crate, and kind of ran into this thing where it's kind of an intractable problem because you compile a component, a WebAssembly component, to run on anything, right? And then uh, you don't know ahead of time if you're going to have Neon or AVX512 or what have you. What the architecture is, you're not going to know if you're going to have the instructions. Um, and so you can't really do good LLVM optimization for running and using SIMD instructions, right? Um, but the really cool thing with with a WebGPU and the promise of WebGPU, right, is that we have a nice interface that all of the architectures support. So we don't have to have any architecture specific instructions. We just have WebGPU. And then we can pass, SIMD-like instructions or, you know, uh, um, heavy compute stuff, right? To the host, and the host will have the shaders, right? Have the web GPU, the GPU shaders do the work, right? And we can just basically have native runtime, native execution. Sorry, I'm just totally thinking of this. This is all right out of my head right away.
No,
So
no, no, this is great. It makes a ton of sense.
apologies.
Yeah, I
So
think
so yeah.
you should probably describe what WebGPU is.
Oh,
Like,
okay.
where is it supported?
Yeah. So when we had so like back in the early days of the death of Flash, which made kind of the same thing, the same ashes of Flash, right? That spawned WebAssembly came a need to display graphics on the web, and so that started with WebGL. That's the standard kind of based on OpenGL, which is kind of an open source version of DirectX. And I might be getting this wrong, I'm not a
Sounds right to
graphics person,
me.
but okay, yeah. So that's my impression, right, as a non-expert of where it was. And then start about 4 years ago or so, WebGPU really took off because there were limitations on WebGL with its kind of OpenGL ancestry. The things that were meant to be done, envisioned that for the early 2000s, right, just weren't the same use cases that people needed today. You also had it's kind of similar to parallels to Vulkan, right, on in the open source world, and Metal too came out, and lower level APIs like DirectX 12. So that kind of from that world comes WebGPU, um, and allows you to do a lot better stuff on the web, right, um, in terms of graphics and shaders and displaying and 3D animation, right? Um, so yeah, so that's the motivation for WebGPU, and that works. That's supported pretty much everywhere except for Safari, the typical support pattern. Safari, I think, is a little laggy on it. But we use it at Adobe for things like Adobe Express and Photoshop Web. Um, and so yeah, so but the nice thing too is not only is it for rendering, 3D rendering, but it's also used for machine learning, right? And AI inference, which I don't know if everyone knows, but it's kind of important, kind of a big deal right now. So yeah, so that's been my thing. We've got some open source models for watermarking photos, for watermarking images that Adobe has, and they're open source. They're TrustMark. I gave a talk about this last, was it just last fall? Seems like a million years ago.
Last fall with the Onyx runtime stuff?
Yeah.
Yeah, it was.
Yep. So I did get it working. I got it working last fall. You could do WebGPU through a WebAssembly module, like a P1 module. I could not get it working for components. Um, and so it really wouldn't work with wasmCloud. Like essentially, I could only make it kind of work as a CLI, right? I couldn't make it work as a component. And that was kind of where I hit a wall in November, and I did not really get any farther than that. Mendy helped out a lot with that, just to get that working at all, and that was in my talk. But yeah, so if I actually want this to be a service that does watermarking, then I need to have it really work as a component, work in Wasmtime. So yeah, so I kind of got stuck. And then this past few days, I kind of had a little bit of time to like do my own thing. And so I got the component WebGPU component working. I hope this is interesting. I feel like I'm just talking into the void here, but anyway, so yeah, it's demo time. I have well, also I guess maybe I should. So I'll just show you what I have. Let's just see. Um so I've got a GPU here, little wash devery here. So I have this single component I've made. It uses the WASI GFX work. Some changes I made to WASI GFX. It uses the fork of Onyx runtime, and it uses this TrustMark model. That's what we call it. And I've got one that says use WebGPU, and I've got one that says don't use WebGPU. And so let me just make sure it's still running. I don't even know what's going on. All right, so if I go to pgrep, okay. All right, so it's still running. And I've got these two running. One is running with CPU, one's running without. And it's already been warmed. The shaders have already been made. And I'm going to pass. Is that actually what I'm going to pass? I'm going to pass. Sorry. Image. Shoot. I'm sorry. Better prepared. Could have been better prepared. Test image is what I call it. Okay.
Nah, I mean, this is how you prove it's live.
All right. Yeah.
It's better this way than when it breaks.
Okay. Yeah,
Not
so
gonna
I'm
let
using
anything jinx
this
you.
test image, and oh, I'm out of the buffer. Okay. All right. So yeah. Okay, so I'm just gonna run it. I'm using this image. I'll open test image real quick. So what is going on? Okay, so yeah, this is really bad. Sorry. Echo test image. That's what I called it, right? No, it's not what I called it. Test image. Huh.
Yeah, your curls came back weird. You were saying just
Yeah.
earlier
Oh, okay.
before the
Hold
call.
on. It's just you're gonna see some history here. Oh, come on, Colin. Sorry, it crashed and I had to reload everything. And now what did I set it to? I mean, I can find it. It's just gonna be hard to do on a really little it's gonna be hard to find on a really little screen. There we go. All right, so it's this. It's this. It's a little image. It doesn't really matter. Like I can give it a big one. It gets resized. I had to do some bunch of like non-GPU stuff around like OpenCV and stuff, which doesn't support WebAssembly. It doesn't really matter, but here this is kind of the test image. And now I will actually curl it here. So there we go. Okay, so now I've curled it. It's a little faster on the on the GPU. Obviously, you'd want to batch it. It's about, I think it's like 80% or it's like 20% faster. And this is also because unlike the demo last year, I've done the optimizations, the runtime optimizations. So it would actually run fast, even faster. Um, but yeah, it's pretty quick. The CPU is quick. The GPU is quicker, about 20% faster. Um, the If I open up the GPU, so here's the GPU one. So yeah, it looks just like it did before, but there's a watermark in there. And in fact, if I use like a native, if I use like the CLI tool, I'm gonna be able to, I'm gonna give it that image, and it'll find the watermark in it. So it's actually been applied. Um, but yeah, so like um, this is like that's I mean I guess that's the demo. But the implications of this are pretty big, right? Because now we can have native WebAssembly performance for workloads that are, consuming all of compute and memory and everything in the world, and we can expose WASI to as a really viable and perfectly and solve the problems that WebAssembly solves without the drawbacks of performance for AI workloads. So probably should have, fireworks, but it's a really big deal. I've been chasing this for a long time, and I think it's gonna be awesome. So very understated, sorry, but yeah.
Yeah, that was awesome, Colin. Frank's got a question for you.
Yeah, so you're using what, WASI P2?
Yeah.
Just wondering if WASI P3 will give you better performance.
It will, yeah, it'll make some of the stuff a little easier. There are definitely some asynchronous calls in GPU, in WebGPU, right? It's made for the web, it's made for JavaScript. So yeah, it'll give you some bumps. There's also the concurrent, there's the cooperative threads, which might give some bumps as well. But that's mostly in the pre-processing and the post-processing because the libraries like OpenCV are made to do that, right? When you give a model, an AI model for like stable diffusion of an image, it has to be, that image has to be manipulated a bunch in order to pass it to a model. And so those images are typically heavily dependent on multi-threading. And so while once you get that tensor in the right shape, right, and then you pass it through the WebGPU boundary, it's all on the host side. So there isn't really a lot to be gained from the Clang work and the P3 work once you get to that point. But certainly all that pre-processing, post-processing definitely help.
So from the uh, so I mean, so you have a WASM, let's say, code, right? How does it, from the runtime, how does it figure out, I mean, what's available and how you do the binding for the runtime?
Oh yeah, so I mean um there's a few different things. So this first off, um, WasmCloud is the only thing that implements both WASI HTTP and WASI WebGPU. Really, there's nothing else that does it. It doesn't. So I just all I had to do, I had to make us, there's um the only thing I really had to do to modify what WasmCloud to be able to do this is I just changed I just pointed the watch time run at my fork my commit of the GFX runtime, the WASI GFX runtime. And then I did some watch stuff just to pass the environment, really trivial stuff. Um, so um, so the host knows that it implements WebGPU, and it passes that capability to the guest as it would any other interface, right? Where Bailey can explain this better. But yeah, so it's a host. The host can provide WebGPU. So if a guest asks for WebGPU, it can provide it. Now, on the host side, if you're talking about like how does the runtime know what's available on the hardware? That is actually a lot of the kind of stuff that I was doing. But yeah, does that make sense?
Because I mean, there are different GPUs and there are different even say let's say CPU dependent instructions that actually can use for acceleration. So I'm just wondering about this mapping. How does it from your WASM or from your WASM code? How does it get mapped into figure out and making use of the?
Oh yeah. So the WASM code is just calling. So the web GPU bindings are generated from. I'm sorry. They're generated. Here we go. Whew. They're generated from these WIT files. This is terrifying too. Here we go. All right. So hopefully, yeah. Okay. So nothing proprietary, nothing I'm gonna get in trouble here. So these are the WIT bindings, right? And this I didn't have to change this. But then if you generate C++, because I did everything in C++ just to make it even harder, then no, not to make it any harder, because Onyx Runtime's written in C++. But these get all generated into C++ header files, essentially, right? This WIT gets converted into C++ header files. And these functions are now available to the guest. Does that make sense? Does that answer your question?
The guest here being the WebAssembly code.
Right.
The WebAssembly
Yes.
code. Yeah.
Mm-hmm. Got it. Okay.
Yeah. So it's non-trivial. This is a fairly extensive WIT file. And the real challenge was not all of this was implemented in the runtime, in the WASI GFX runtime.
And when we say WASI GFX runtime, I'm not going to ask you to navigate anymore, Colin. Actually, I take that back.
This.
Okay.
It's this.
Yeah. So essentially, this is something that Mendy maintains, and these are WASMtime bindings on the host side of that interface definition that we just saw.
Yeah. So I just had to add these for my stuff, for Onyx Runtime, and my particular use of Onyx Runtime to that and associated header changes.
And then in WasmCloud, we point and pull in this. And so every time we update Wasmtime, this is one of the fun challenges that we have on our upgrade path, and that Mendy revs this for me to be on the latest version of Wasmtime, and then we pin directly to this as our dependency. And so because these are host bindings, you bring all of your host bindings together at the same time. And so then in WasmCloud, basically we have a feature flag for turning this on and off. I will say in the Rust guest side of the world, there's a crate called WGPU, which has the bindings in it, so you're not like navigating the headers and things like what Colin did for his C++ side of the demo. So it's, potentially easier in Rust, but I think reality is that there's just so much existing code today that can just work if we get the C++ path ergonomic and nice.
Yes.
Yeah.
All right. Yeah. So this is, yeah, still working. It's still a draft, but I just have to point my Onyx Runtime fork. That was a fork of Mendy's stuff. That's a fork of, sorry, my fork of Mendy's, which is a fork of the actual Microsoft Onyx Runtime. It has a lot of stuff in it that's like not ready for a real Microsoft pull request, but it works, right? Yeah, so it's working, but still needs to be cleaned up quite a bit.
And I'm wondering if anybody experimented with the Rust bindings.
Yeah, well, you can actually look inside WasmCloud. We actually have a unit test for it with the Rust bindings.
Okay, cool.
Yeah, I'll work on grabbing a link of that. But yeah, the Rust side is much better paved, I would say, right now.
Yeah, so this is And this is the Rust bindings for the Onyx runtime. So this is the Rust bindings for the C++. So yeah, there are a few different levels, right? So you can just take it at the header level, and there's what Bailey just mentioned. But if you wanted to like, well, I've got an Onyx model or an ORT model, and I want to run that in Rust, then we have to go through the Onyx runtime gets the changes, and then the bindings get generated for Rust. But I don't know why I digressed that way. That's kind of a digression, but yeah.
Okay, thank you.
And Dan?
Yeah, thanks. Colin, that was a really cool demo. I'm really interested in all this stuff. I've chatted with you briefly about it before, I think. I was curious, it was touched on about different types of hardware availability and things like that, and thinking about WASM being this kind of universal target. Is there a way, like, what are some techniques for discovering this stuff at runtime? Is that baked into the sort of spec? Like, if you wanted to discover what capabilities you might have hardware-wise at runtime, like with the same binary, is that something people are exploring?
Yeah, that's kind of the problem I was talking about with SIMD
Yeah,
in a way, because you can't. I think what you're saying is that you can't, just like the nature of WebAssembly, you can't know the instructions that are available
right.
in the host, especially like pre-compilation. I think there's been some work around relaxed SIMD that I'm not super familiar with to try to address that, I believe. But no, so that's an actual like real problem. So getting in the browser, sorry, in browser WASM, in JavaScript, we need standards to allow for querying of hardware specs. And those are going forward. And so I guess we would need similar if we were making sort of runtime decisions on how to execute a workload.
Hmm.
I would say like that's kind of your question. I think
Yep.
I think on the server side it's a lot less of a question because
Sure.
we know the hardware in our setup, right? In our
Right.
platform. And so we could like already just to make those decisions already. It's when you don't know what it's running on, which I guess we could like I would love a world in which WebAssembly runtimes are so ubiquitous that you would not know ahead of time where a workload is running. That would be really
Criterion.
cool. I think we will
Yeah.
get there.
Yeah.
But I think yeah, we're gonna solve that in the browser, and then hopefully we just pick that up.
Cool. Yeah.
Hey, Liam, you missed an awesome demo.
I can't wait to see it.
A
Yeah.
lot of bumbling. Play it on double speed, please.
Oh, come on, Colin. Be great. I can't wait to see it, bud. I missed you.
Yeah. So basically, the thing that we were that was so hard, basically in November now, Colin's got drafts PRs up that have it working. Sounds like we've got more work to do on the Onyx runtime side. Totally chill, but just showing that it can work end to end is pretty huge. There's a little bit more that we want to do on the WasmCloud side of this. Like, we learned and Mendy put in an issue this morning about it, where basically we're shipping muzzle binaries, and we want for specifically because of GPU, it's much better if it does glibc. And in our Wolfie based images that we is what we build on and ship for the WasmCloud host. Right now, they actually also recommend that use glibc, and that should just work TM with the Docker containers or Docker images that we already built on. So, first phase, we need to just go ahead and create different binaries that we build as part of our release pipeline, and then we'll switch to those binaries in our Docker host. And then that way we don't have to do anything too tricky, like, well, only for this binary could you do WASI WebGPU. And basically Colin's demo worked here because he built Wash locally.
Okay, that's amazing. Well, the you've seen some of the some of the demos I've been building, building with customers. I think, with WasmCloud too, it's just never been easier to build with, with WebAssembly. Like, I was able to single shot some pretty complex applications with Opus, and like then it was just iterate to make it pretty, and get things out. So I think we've definitely, crossed this chasm of a world where people, cared about, they've stopped caring about how things happen, and they're just moving to focusing on the what needs to happen, from a developer perspective.
Yeah. And I love it because that basically means more people are going to be willing to adopt Rust because they can just ask an LLM to build it and it will do an excellent job. It's
Yeah.
probably the easiest language to target with an LLM. The compiler
Really-
tells it what to do.
Yeah. No, it's great. It's like a nice convergence of two different things, right? Which is the security stuff that's being pushed in the effort to go into Rust, and then plus the LLVMs. Yeah, perfect. Hopefully, a perfect storm of WebAssembly adoption.
Any other questions or comments on our GPU side of the world?
Yeah, on my side, if you may,
Hey,
if I may.
hey, good to see you again.
Yeah, likewise. So I've been definitely playing a lot with this WASI GFX work. I have quite a few demos of different things. One of the things that I've been really interested in is because for some of our use cases, we want deployments that don't have any UI because we just need WebGPU for acceleration, especially on cryptography. But for some cases, we do want the user to be able to build an application with a UI. The problem is that in our situation, we need sandboxing. And it's very hard to tell people like, oh yeah, just rewrite your entire UI in Rust, which is doable, but like most people don't want to do this. And the problem is, of course, if you want to use HTML, you're kind of outside the canvas, so you can't easily apply a lot of the WebGPU stuff to it. And so you have to do a kind of hopping back and forth where you lock down the HTML side and then you take screenshots and send them over to the canvas. But there's this new project called HTML and Canvas you might have seen recently. Came out in Chrome like a week or two ago. And it allows you to pass in HTML directly into the canvas instead of like the previous screenshot approach. So I'm really interested in trying to see if I can get this to build like a safer container for this like rendering where you can still render like proper HTML so you still get accessibility or like text selection, these kinds of things. So I'm hoping that with this I can solve some of the issues with my like existing WASI GFX demos to kind of unlock stuff. So I'm gonna try to find some time to work on this.
Well, there's no one better to talk to about it than Mendy. Hey, Mendy.
Hey, yeah, Sebastien, nice to see you again. About that HTML thing, there is actually a renderer, an HTML CSS renderer being developed that's backed by WGPU. I've been wanting to get an experiment running it inside WASI GFX. I haven't gotten around to it, but that's a very cool project. It's called Blitz. I don't know if you've seen it, but just
Well, I haven't, but I'd definitely be interested because I
I'll post the
built
link
like
in
a
chat.
demo of like this HTML canvas stuff this weekend. I'm still trying to like sort out some of the issues and what you can do, what it does not allow you to do. There's an alternative. I'd definitely like to check it out.
Does it use JSIR? Any of that stuff? I don't know. Just trying to
I don't
get
know
up
what that
on
is.
the JSPI, JSIR stuff.
Oh, okay, yeah, the new name,
Sorry.
This Colin's showing he's hip. He knows.
I go to the meetings. I just try to
Yeah,
sit there
he
and
knows the
look
latest
like I'm
version of
not-
the spec. Yeah, I actually I didn't I'd forgotten that it had changed from JSPI. So yeah, awesome. Okay, so I hope so. It's gotta, right? Like if it's modern, we should judge them if it's not JSPI compat. But maybe they don't because they want web compat. This
I
is
don't
one
know.
case where server side's further along.
Yeah. Yeah, it would be good if we just yeah, I don't know.
So part of the reason why this matters is that let's say you decide to write this stuff and use Jco to compile this as a component. So you take the JavaScript bindings and you put that inside a WebAssembly component. The way that we're doing WASI P3 is with JSPI. So if they're building with that, then we can have some really nice, very performant bindings that feel ergonomic and normal. If they're not using that, then we're going to have to shim it, which isn't the worst thing, but you know, if you don't have to shim things, that's nice.
Yeah, so we should probably follow up with who's working on it. I'm looking at it now. I'm sorry. I'm now looking at this HTML and Canvas.
Yeah, successful nerd snipe, gotta say.
So they're all. I'm not in any meetings with these people. Is this the engine side, or I'm sorry, who are these people?
So it's in Chrome. It's only in Chrome currently. I think Firefox is like interested in implementing it, but I don't think they've started yet.
Yeah. So it's. Do you even know which Chrome team and who? I've got some
I
names
don't
on
know.
here. I don't know them, which doesn't mean anything. I don't know one. Doesn't matter. But Philip Rogers. It would be cool if they were plugged in, or if we. I don't know. Being recorded. Like I know something. People are gonna. If anyone ever watches this, they're gonna think I know anything, but I don't. But yeah, it would be cool if it was in that level in the JSPI, and then we could make it work without shims.
Are we
Yeah,
gonna do
maybe-
the after meeting, Colin, when we stop recording and broadcasting?
I'm so sorry. Yeah.
Okay.
I mean, the 200 regular watchers of this community meeting
Right.
on YouTube
They
are
might talk
all
to
going to
somebody
be
else.
really curious. So it's colin.murphy@adobe.com. I just made that up. I don't know if that's
Oh
it or not.
no.
Yeah. Well, if you guys want to like share extra info, I think Colin's on our WasmCloud Slack. That's a good place to connect with him. If you want to send him a DM on any plots there, he's got connections. We should use them and make cool things happen in the world. All right. So I'd say that's the last of it for that first agenda item. We've got a couple more actually to run through. I'm not saying it's a packed agenda, but there's just stuff that I wanted to make sure that we shared in the community. The first and well, I guess the next thing. I put up this proposal yesterday mainly because I was asked, to go ahead and cut another release because we'd had some really good bug fixes in and we wanted to get that out. I was like, well, it's kind of, I don't want to be the only one that holds the button here. That doesn't feel right. There's always like a little extra communication churn and people not knowing specifically when their fix is going to land and when it's going to be available for their end users. I want to actually add some expectations that people can have. I did sort of pull the date and times out of a hat, but I had some motivations for it. So what I'm proposing is that we do automated releases every 2 weeks on Tuesdays. Tuesdays specifically because Mondays, you're still getting back, you're still getting the swing of things. Fridays, no ship Fridays. And so you ship on Tuesday, deal with any outcome that might happen, any kind of follow-up you have to do during a normal work week. And so this way we can roll out a release and people can depend that it'll always be there. Now, pure somebody that's just implementing a train release model, they would never even have necessarily out of band releases unless it's a hot fix. And I'm essentially saying basically I want us to be able to do hot fixes. So if there is a patch that we need to make, we can do that out of band. But you can also guarantee that we will always regularly ship every 2 weeks. And that's basically it. We already have sort of like automated releases right now. Today, I manually bump all the versions, and then I create a release. And that's basically it. That's the step. And then that will go and run our release pipeline and put out release images. So the other key benefit here about having regular automated releases is that you will always have automated releases because, you're doing it, you're going to maintain the automation and the push button. So to me, that's another big win for doing this. And I just wanted to put this out, make sure that like timing wise, predictability wise, consumer wise, that this is what the community wants and it sounds good to folks. And if they say yes, then the steps to do it are pretty basic. Something that I could get done in, a day. And we just have a regular train model for WasmCloud v2. Thoughts or questions on that one? All right, cool. Yeah, I've chatted with some of the maintainers, so we think this is generally a good idea. So if we're good with that, we'll just roll with it. I'll take this chance to just go ahead and bring up our current roadmap, just to show where we are in the cycle. If we go over to projects and WasmCloud roadmap, essentially, we've got a few different things that we're building out. We have a couple things already completed, which is sweet. So this was a big one that Jeremy got over the line. And then we've also made it kind of separate from that, but in the same domain of making sure that we also have TL support for when you're running WatchDev locally, and making sure that the experience between the two is aligned. And the way that you plumb all of that also included some of the chart updates. So in the latest release in WasmCloud 2.0.4, basically you've got, like all of our Helm chart patches that have been made so far. And I don't think we're aware of any other kind of Helmy type bugs or changes that we're planning to make in the near term. Some of the things that are in progress. I want us to have CI publishing for a Wash runtime crate. Right now, we're not actually publishing that. Aditya's got a PRN for HTTP client plugin. I've got a PRN for micro benchmarks. And I still list this one as in progress because I have a couple follow-ups that I want to do for our better P3 support. But in terms of things that are kind of in flight right now, that's sort of our main set. I'm going to pull this one up real quick. So we had an end user report performance difference that they saw between P2 and P3, and also performance differences that they saw between WasmCloud and Wasmtime. And so I went and added micro benchmarks to have basically a baseline of like what does just Wasmtime serve give you? What do you get also with just like the way that we actually use Wasmtime, which isn't through the Wasmtime serve interface, and then also compare that in a matrix between P2 and P3. And I found some interesting things. So if we, as I ran this, basically what I discovered is that there's a new really awesome feature inside Wasmtime for reuse. So is this my actual PR? I did this dance earlier. Let me just go straight to it. Pull request. And if we go to the one for the micro benchmarks, and this one right now is just focusing on HTTP being your invocation route. But essentially, what I found is that if you're using Wasmtime serve and you're doing it with P3, you get a pretty significant performance boost if you're using the reuse path. So that is really cool and awesome. So I want us to use that. So then I started working on that, and then I ran into an issue. So I filed that as HTTP reuse here. And essentially, we've got an interesting challenge where we do basically cross-component linking for people at the host layer. And when you do that and you're trying to communicate over a store that's kind of like pushed down into a different async runtime, I can't talk to it. And if you try, you'll get an error. And so to fix this, I started looking at some of our options. I'm just gonna jump right to the one that I want to do because all the other ones feel bad to me, TM. And it's actually what we've always wanted to do. Our intention from the very beginning of like, what's the definition of a workload deployment, where you have n number of components and a service, is that your service is basically like your root of your application, and then all of the other components are basically like a subtree. And so when you resolve this workload, it is one component, is kind of like the way you should think of it. And that's why it acts as a single unit of tenancy. So it's one thing. But we didn't go ahead and do composition ahead of time because there's this really cool feature inside the component model that is being developed but not available yet called runtime instantiation. And so with runtime instantiation, I can basically, it does what it says on the tin. It instantiates at runtime, where if I have a root component, let's say our service, that's long-lived and it lives for a while, but we never actually need to call into any of those subcomponents. They're not instantiated until we actually need them. And that can be really useful, and part of the reason why Fastly and other CDNs are super excited about using that feature inside the component model is that they want to be able to say, okay, I have an entire site with many different slash paths, right? Like I have one for this CRUD service, I have another one for this other CRUD service, and I want to be able to scale them all to 0, right? Like I want to use as little compute as I have to, because we can start in microseconds. So let's not instantiate until we have to. And I want to basically have a router component for my top level of my app. And that router will then instantiate as needed the subcomponents. So I wanted to wait till that was available to be able to do this. It's not available, and I want to take advantage of reuse right now. So my idea and what I'm proposing here is, okay, service obviously has its own lifetime. It's long-lived. It has a different lifetime than our components that are sort of our stateless components that are part of the workload. So why don't I do the first part of this composition, which is composing all of the components and the workload deployment together, making one component there, and make that separate from the service. And so I'll still do the link with the service, but the service intentionally has a different lifetime. We use that so that it can have some state, like holding onto a connection pool and that type of thing. But for the things that are supposed to be serverless, I keep them serverless, but I still treat them as a whole unit. So I instantiate the whole thing. That's the negative here, is that I'm instantiating the whole thing. But my theory is that most of y'all are not yet making a ton of different components in a workload deployment. And if you are, you have an easy workaround to say, I'll just make a separate workload deployment. If they really have totally different lifetimes and different scaling properties, then I'll just make them as a separate workload deployment. They can talk to each other over HTTP, and that's an easy workaround where the other one maybe would never get instantiated while this other one is running. So my thought is that while that is a downside, that's like significantly less of a downside. And so I've been playing around with that, and building on top of a lot of that, basically locally, this is the bench I just ran, with reuse, we make up that difference with Wasmtime. It's sort of the TLDR here is with micro benchmarks and doing HTTP reuse, we have a really nice throughput, and basically any difference that we have, for the most part, is largely just noise, which is exciting. So I'm pretty happy with it. I mean, obviously it's not same, right? Like we do have a couple more extra calls that we make in the hot path that you just can't get rid of. And a lot of that is for like our enhancements, right? Like doing the right plumbing to do the right plugin, doing the right plumbing if it's talking to a service. I think there's probably more low-hanging fruit here, and I have burned down several other things in different branches that I need to run this bench against. Specifically about trying to reuse objects as best I can, do a ring buffer at a couple different places, etc. But I'm overall pretty excited and happy with the outcome. It's a good bit of code. I'm gonna just pre-thank my reviewers on this. Whoever takes a look at it, I appreciate you. I'm gonna try to break it down. So basically, I'm gonna do a PR probably either later tonight or tomorrow on doing basically the component composition as part of workload deploy. So like we pay that once and then we cache that. So we only do that composition work once. And when you do that, there is a cost, right? Like running, basically it would be an embedding of WAC graph. So like I can basically create a composition graph on the fly of the workload deployment, run the composition, basically get one .wasm for all of my components, and then also I would still have the other .wasm for the service. And then I pass that one to basically Wasmtime, and then underneath it runs through CraneLift, and then it does a lot of different optimizations now for doing those calls versus me doing some host magic for doing that linking. That'll be my first PR. That'll probably be the bigger one. The HTTP reuse one, easy peasy. So thank you. That is my topic on that one. Any questions on that?
Yeah, we ran into similar issues. So we were trying to similarly have like a proxy that accepts requests and then proxies it to a list of possible containers or components rather. The way we currently have this working today is that basically the top level component receives the requests and then creates a in-memory WRPC connection to the component of choice.
I see.
It does like a one-shot client and then returns the result up. So we had to make some changes to like WRPC to support this. But it doesn't do any kind of like clever reusing. So this might be like a better solution, especially if there's like a way to natively instantiate these components at the component model level. Because right now we have to like hop through the host to have the host instantiate on our behalf.
Yep.
So
Yeah.
definitely be interested to review this.
Yeah, so I mean, for this one, basically, for if you're using HTTP reuse, it's a 5x perf improvement, which is pretty big. I am working on the benches right now for the composition, but I think in the long term, that is always going to be way more efficient than us constructing the linking ourselves, because if I pass a .wasm to wasmtime and then cranelift's going to build machine code for that .wasm for the lifting and lowering instructions, which means it also is able to do optimization paths to say things like, okay, this this component and this component inside this one component tree are talking to each other over their interfaces. Then I can say, oh, well, that's doing a string representation in one component in Rust, and this is also doing that. And so when I lift and lower these, it's actually all the same opcodes. And I could just eliminate those and just do basically a mem copy. That's the type of stuff that you could get out of your runtime if your runtime is in charge of figuring out how to do that linking. I think today there's probably a lot on the table that is not being done. However, I think in the long term, that's always going to be the most performant option.
Yeah, and I think one of the challenges that I would have to tackle in this case is that if you have too many components to fit into memory, because for our case, we probably have millions of components. We'd have to somehow like cycle these if we have like the component itself be in charge of like managing these links. But that might be too tricky.
Yeah, I mean, I think, for a lot of that, right, it's about putting them on different hosts. And then also creating essentially an affinity via host labels for breaking down components that are chatting with each other. So there's probably a lot of different workload placement strategies that you can take advantage of to really kind of like be efficient about the hardware that you're using and not, trying to run them all in one place. There is something else that did come up in a conversation this morning with another end user where they wanted to be able to essentially have what you're talking about, Sebastien, which is have sort of like an in-memory map routing between different workload deployments. So not just inside one workload tenant where they can talk to each other, where we do that automatically, but also being able to do that. I deploy 5 workload deployments. Well, I don't want to when I'm on the exact same host, do I really want to drop out to the network or drop out to something else? Can I just do all of this internal routing internal to the host if they both have the same deployment? That's sort of a pretty cool and powerful feature for a serverless FAS type platform to have. I think it should be an optional plugin because I think for a lot of reasons people have CNI and network policies in place, so they kind of have this expectation that things are going to drop down to the network and back again. But another cool place that I think we can get some pretty sweet performance gains.
But Bailey, this would be the like in Kubernetes, this would be like the service interface, so you don't have to go all the way up to the HTTP stack or the TCP stack.
Well, if you would have to if they're on different hosts, right? Like if you're doing cross-host communication.
Correct. If you're in the same host.
Oh, yeah. You're saying do DNS routing for this effectively, local.
Yep.
Yeah, I think that's how we would implement it. And also use the DNS name that we've created with our operator, right? Because it's our operator that's making sure that you have these headless services. So you already have basically the DNS routing in the service. So when you realize, oh, I can't talk to this workload locally, let me do a call out. I guess, Frank, the difference here is that I'm saying like maybe we're not even doing HTTP requests here. Maybe we're doing function to function requests.
Yes,
like
absolutely.
with WIT. Yeah. But in the case that they're on a different host and we need to do a cross host, well, we can make an HTTP call straight to the headless service, effectively, which would go to whatever your proxy is, whatever your gateway controller is. Like let's say it's Envoy, and then that could route to a different host that doesn't have that workload on it.
Mm-hmm.
Yeah, I think it's a nice thing to have. So I feel like that's very much kind of in scope for this roadmap. So, but one of the biggest things that I think everybody called out was wanting to see more types of benchmarks, And so we've been pushing on that pretty hard. Yeah, I think that is largely a lot of it. Yeah, Dan.
Sorry, I was muted. I was curious about where I could read more about the runtime instantiation that's going to be
Ooh,
landing soon in WASI. I'm familiar with early discussions around it, but I think it was like 2 or 3 years ago that it first came up, and I was googling it too. I just didn't know what the most
yeah, this is it.
up
This
to
is the thing.
date. Okay,
Yeah, so Luke is, awesome to work with. He's really good about planning multiple years in advance. Sometimes it feels like he can see into the future.
yeah,
Um, so this is the one that he's using to track runtime instantiation. This feature is actually dependent on a couple other features that we're adding to the component model. So it's actually in a queue of things.
okay,
And then the next one in the queue you might have heard is called child handles,
yes,
which is
yeah.
part of being able to do basically child callbacks with scope, which is a feature that the browsers need for us to implement the component model. But basically, once we have that, it's a lot easier to basically use that as your scope wrapper for doing an instantiation, so that one component can basically reference another component. Is essentially what it comes down to, and that's how you do the runtime instantiation.
That makes sense. And there's even core WASM dependencies on this too, if I'm not mistaken, right? Because there will need to be, or we can talk about this later too. I was just curious about this sort of, Luke told me one time about this POSIX spawn equivalent,
Oh,
and this
yeah.
this kind of like, in one fell swoop. Well, yeah, there it is. It solves kind of the DL open dynamic linking problem, and kind of the famous, the fork exec problem, but in a different way. And basically, I remember talking to him about this, and this just reminded me of it, and I'm just curious where the most up to date stuff is. I can just dig through this stuff. I just didn't know if you
Oh,
knew
yeah,
anything about
it is usually easier to chat about it. His thoughts on that are, roughly similar to what you just said. I wouldn't change anything other than we have found that we can do canon built-ins for all of this, and so we don't actually have a core WASM dependency. And a lot of that came from the iteration that we were doing on cooperative threads, which has been
it.
making awesome progress recently. So, like, basically, once we figured out, oh, we can do stack switching, threading all at the canon ops level for the component model, we can also do a couple of these others that we want to add there as well.
That makes a ton of sense. Yep. Okay.
Yeah, and one issue that we're also blocked on for this is that currently you can't do recursive reentrancy.
Yes.
So you can't have like a instantiated child and then have that child come back and call the parent.
There is some thoughts on that. That one I'm gonna have to defer to Luke for the full answer. I've heard him try to answer this. I'm not sure I grokked enough of it to concretely imagine how the ABI will look for it, so I don't want to say too much out of turn, other than they're all kind of tied together in making it possible to reference. So there's just this kind of cluster of several different features that all I think we'll be able to decouple them, but we have to design them all in concert, basically, because they're all going to have to work well together. Yeah, Frank?
I was just wondering if you could add some more details on your performance.
Sure. Well, I think the interesting part, I think if we dove in a little bit, what I like about micro benchmarks is that you can you can make it exact to what you're trying to study versus having a lot of noise. I mean, I'm still doing network on this one, which is not a pure perfect micro benchmark. So there's more that I can whittle away at it. I actually created a bunch of other little ones that I used to like debug this to figure out where it's at, and most of them I wasn't going to contribute back because they came up with nothing and it's not really that interesting. For example, like I just had a bunch around store instantiation because part of the win here for the proxy handler reuse is actually specifically the store is the thing that you actually keep alive. And by keeping the store alive, that's where a lot of the basically object allocations happens. So the name of the game here is like no Alex. Let me grab some of the code here. So I haven't done a ton of Rust benchmarking. I, for the most part, studied what Nick Fitzgerald does in Wasmtime and tried to be more like Nick. But I have run into something where and a lot of the ones that I was looking at and most of the Rust projects I was pointing at all were using Criterion. But something that I learned about today is about IOPS from Valgrind, which will do CPU instruction counting. And that should give me some better, more deterministic baseline so I can eliminate a lot of the noise versus what I'm doing with Criterion, which is giving wall time. Um, is that the kind of detail you wanted to hear, Frank? Or
And even going further, is actually, so how many times did you run this? So
oh,
so you get
yeah.
some kind of
Um,
confidence intervals. The other thing is actually, even if you take CPU and so forth, it would be also interesting to say, okay, what's the wait time? Because I mean, yes, you have the number of instructions, CPU instructions, so forth, but then you have in terms of either swapping or some other things that might give you some latency in terms of when you really get to the execute instructions and so forth.
Certainly, yeah. So in terms of the benchmarking science, it's still very early. I have a Linux box that I play with sometimes that's kind of crappy hardware, like it's my old gaming PC. But what I really want is to set us up with something on Hetzner for a dedicated Linux box that we can actually run over a long period of time. Obviously, we want something that's bare metal so that we're not getting noise introduced from virtualization. But I haven't set that up yet. So right now it's out of scope for this one. I still think that we want a benchmark like Criterion with wall time, even though it does introduce noise, because it's very much like the human readable output of how this stuff works versus the other one, which is like number goes up or down, but you don't really know what it means. Whereas with Criterion, I can easily give you a request per second output, and everybody knows what that means.
And actually, when you loaded it, so I mean, you have the number of, let's say, requests per second. How did you, let's say, ramped up and ramped down and so forth? And how did you figure out that that's the number of requests per second you're interested in?
Yeah, basically all of this is stuff that's actually built into the crate that I'm using here called Criterion. But everything that is of interest here is part of like Criterion. I create a benchmark group, I create my sample sizes. This is obviously a small sample size. And from measurement time, I did it for 15 seconds continuously. For like what's my basic bench, I broke down each of these invocations just as cold and warm. That way I can measure what the instantiation cost is for these, separate from once we've already maybe potentially done a pre-alloc. Obviously for P2, there isn't a pre-alloc, so that's why that behavior is basically the same between the two. I think all the questions that you're asking, Frank, are all in this HTTP invoke. And you can easily just take this and run it locally, which is nice. All you have to do is say cargo bench, and you will get that output in theory, basically the same as me. I am doing I have this really. I want to come up with a better way, but I actually, while I was running this, I ran into a regression that we had where we were dropping on a lock. So we were trying to attain a lock, and it was in our dev router, if we didn't actually get the lock, it just continued on and just reported that as a failure instead of blocking for the lock. So that's one thing that I do have changed in this PR. But yeah, this is there's benchmarking is its own special rabbit hole that you can go down for weeks. I wanted to get some of the basics in. I do think that if anybody's willing to dedicate bare metal hardware that I could trigger workflows on, that would be super appreciated. I did put in a ping to the CNCF help desk to see if there was any resources that I could use or API keys. We used to be able to use Equinox. I don't know if I'm saying that right, but that's not available anymore. So, what can an open source community project use that's as cheap as possible, but also bare metal so that we can actually, run these things And I definitely don't want to run this on my MacBook because so much of this performance is actually very dependent on Linux, where basically copy on write, for example, is a default WASMtime feature that is only enabled on Linux, which, you know, it's like copy on write for your memories. And so keeping your memories around without having to like clear them is obviously a pretty big performance boost. You know, some people will disable that if they're like a CDN and they're hyper security sensitive. But I digress. There's a million and one knobs and things to do here. There's so much fun stuff. If you're interested in any of these, I have plenty of. I have this like captain's log of like all the things that I wish I could come back and do. But I just wanted to get the basics just for this HTTP reuse captured at least.
Yeah, I'll look into this. I mean, we could use mini PCs for this, right?
It would be really helpful. Yeah, I mean, honestly, so long as it's a consistent hardware, right, that looks somewhat like what people would run in production, you know, Linux of some kind. And we're able to kind of like consistently get a baseline. That is another thing that I really like about Criterion is that it's got a baseline flag. So I just like I ran cargo bench dash dash baseline, and then I said okay like pre-reuse, and then I ran it again with my patch applied, and then said reuse as my baseline, and then it makes really nice HTML diagrams to be able to diff between the two. So I was pretty happy with it, but again, you know, I grew up in the probably closer to what Colin does, which is like C++ data visualization benchmarking, and there I always used Valgrind. So the idea that there's actually a cooler Valgrind, but also Rusty implementation is pretty interesting to me. So I kind of want to play around with that. Yeah, hey, Ortis.
Hello.
How are you?
Question for you.
Yeah.
Do you have a repo that is literally a clone or a Docker image, and ideally a Kubernetes manifest that I can just run in my home lab and I can report for
Yeah,
you?
we got all kinds of stuff. Okay, so I mean, you can just run cargo bench here, like just straight up Rust will work for this one. Like you don't need containers or anything. Now, if you want to step it up a notch from there, and you're say like, yo, I'm on a home lab and I hate Kubernetes. Okay, so then click this one, and
Yeah.
then
I have
on keys
Talos,
here. Okay, well. It would
which
be
is
nice to
Kubernetes.
have
Yeah.
that. Okay, so if you do have that, this should just work. I mean, basically we have a kind config here, and then you would deploy our Helm chart on it.
Mm. Okay. Okay. Maybe we can follow up on this, but if you make that easy, Bailey, because I'm really busy lately, like I can just run in my home lab from time to time and like report back or whatever. Like,
I'd
yeah.
like to think it's easy. I let me know if it's not. We ship a Helm chart, so I would do a Helm install is the way. I'm pretty sure we even have we definitely have good docs on this too.
Do you have a
Um,
Grafana dashboard or something like that that I can also install to see things?
well,
Here's
I have a
here's the case,
product.
here's the case harness that has metrics and everything all kind of built in.
Okay. Yeah, I mean, I can help. We can talk later behind.
Cool.
And yes, by the way, I'm trying to convince friends to join my Tailscale cluster of home labs to create a private network. Join me.
Contact Yordis on WasmCloud
Yeah,
if you want
no
to be part of
hacking,
his
no
home lab.
hacking. Yes, don't hack people.
Maybe you need to make the rule WebAssembly only. Keep it locked down. Okay, so I think in terms of our agenda, we did Colin's demo. We talked about the training release model. I showed you where I'm at on benchmarking. And I was just trying to make sure that consistently I'm good about going back and doing the roadmap view, just kind of talking about where we are. I think the WasmCloud secret work is something that Jeremy's looking to pick up this week. So that one I think, will be in progress soon. And this one here is actually would be solved by the component composition solution. So we might be able to close that one down. This one's still up for grabs, and this one's still up for grabs, but we have a new community member who joined the call, Dan Phillips, who's interested in both of these. Yeah. Aditya?
Hey guys, I was just wondering about the issue I had put up regarding wasmCloud NATS
Oh, yeah.
and its interface proposal.
Do you want to talk about
and
it?
I wanted to, I want to get a few opinions from the community members.
Yeah, and also I just want to call out we are 11 minutes over, but we are recording, and so you can hop on and watch this if you need to run or anything. Totally understand, but yeah, I want to talk about this. So
Okay.
let's keep going.
Okay. So today NATS is split across two different interfaces: wasmCloud messaging as well as the wasmCloud, the WASI key value store with the NATS backend. This proposal adds a completely first nature implementation of the entire NAT stack with the core key value store, the core pub sub buses, and the Jetstream. What I'm confused about is what is the scope of this new interface that we'd be adding, because obviously we have wasmCloud messaging. Jetstream needs its own persistent handler and key value store. We already have that with the generic KV bindings. I've mentioned a draft interface down below, and I was wondering if the scope looked all right, if we added the core and the KV interface along with the Jetstream, or if we would encourage people to use the wasmCloud NATS interface alongside wasmCloud messaging and WASI key value. And I just needed some thoughts with people about having a full consumer-based mechanism for the Jetstream as opposed to the more legacy-based push consumer.
Well, first of all, thank you for putting in this work. I think this is something that I wanted to see for a while. You know, some people think, you know, Bailey's like obviously chair, one of the co-chairs on WASI, so all I want to see are WASI interfaces. And that's really not the case. Like the whole point of WASI was to just like do the minimum that we have to standardize to bootstrap an ecosystem. And then from there, I want people, the whole point is that we can build these modular interfaces with exactly what we need. There are obviously benefits to making common denominator interfaces so that you have portability, but some of these things never change. And you know, like you're probably not jumping around on databases, right? Like that's a whole operation. And having portability for that is somewhat questionable to me, especially when you're trying to do something that is, you know, you're forcing yourself down to a common denominator. For the most part, like when you're picking a database or some or an event bus, you're picking it because it has a certain set of features that you need. So anywhere where I think for you, for like a design goal that I would want to see is that you've leaned in and said, this is like the best way to interact with NATS. Like that will be the key design goal for this one. And for that reason, I would say don't try to train yourself to make it match WasmCloud messaging, which is basically our like version of WASI messaging. And I would say go for your core and design it the way that you think would be the most like native to somebody that speaks NATS and would recognize that versus what we had to try to contort ourselves to with WasmCloud messaging, which is what would every event bus ever use as their verbs and stuff, which is its own thing. And again, I threatened this last time. Don't make me bring up the GitHub issue with 65 comments on it. Like I can do that again, but I just don't want to go back there for this. I think, yeah. So just making sure that it's the lingua franca of NATS is like what's most important to me.
Keep it the highest common denominator.
Exactly.
Regardless
Yeah.
of the NATS. Okay. Makes sense. Okay, yeah.
And the other side of this is that what's amazing about components, right, is if somebody wants to be portable and do the common denominator thing, you can always use components to virtualize other components. So if somebody wants to write to WasmCloud messaging, but as a platform team, they want everybody to be on NATS messaging, and they want that to be really clear about the component that they're deploying. You can always have the second component that basically is an intermediary between the NATS messaging to the, other direction, from WasmCloud messaging to NATS messaging in this scenario, at a very low cost. Yeah, Yordis?
Yeah, Bailey, one thing it will help, because I agree with everything you said. The only caveat is what this type of WIT files and stuff like that's not telling is the capabilities and expected behavior behind it. So for example, like, okay, where it is a idempotency, right? The duplication messaging. Or like, okay, what is if you have bashing, do you support atomic bashing of or not, right? Things like that. So like, that would be actually extremely helpful to document, though, because maybe your component is already pretending that whatever you're injecting behind, regardless of what it is, at the very least have to support n numbers of semantic stuff behind it. So that would be my only feedback in terms of like what I see, because that have to be extremely clear.
So translating that, Aditya, basically what we would want is that when somebody imports an interface, that you need to think of as like importing a capability. So what Yordis is kind of saying is that we want this to be very granular, so that they're importing like the batch capability or the KV capability, and they may only just be using one of those, and they're not using all of NATS, right? They're using this specific set of capabilities, and maybe they're only reading, right? Or maybe they're only publishing. So being able to make sure that we can write something up that's and the way that I would describe this is probably being declarative about the resources that you need as well. There's this other kind of design philosophy with building out your components to make sure that, you know, if I'm connecting to a database, right? Like there's this that you see, like I am doing an import of a store. And so now I'm operating off of this store. So don't instantiate me unless you can give me this store. So I'm like being very declarative about the resources that have to exist for me to run. I don't want to figure that out dynamically at runtime when I'm instantiating. That's not ideal.
Well, Bailey, to follow up on that, because like, yeah, sure, you could still be specific and say, I need the key value and I need only the put function, right? That's totally okay. But even further, it's like, okay, from the put function, what type of capability I should expect from behind that call?
Can you give an example?
Yeah, to make a point, right? Like, does a put function have optimistic concurrency update, right? Hey, put the thing as long as the revision is in number 5. Is that required or not? Right? Idempotency, idempotency. Like if I do the call twice, like, okay, am I under the assumption that that component that is implementing it would not actually create duplicates, right? It's like things like that the contract itself does not tell you, right? Because the contract just tells you, okay, yeah, here's the messaging in, here's the messaging out. But like what to expect from the system behind is completely different. And the reason I say this is, and this is related to this blog post, like, yeah, when people say KV, sure, KV as in what you actually expect from it. To make a point, what if you have Jetstream with KV and you have actually a geo-replicated thing and you say, hey, technically when I do a put, I don't care about the locality of things because my cluster, whatever the heck, is taken care of. Versus, well, maybe you have a Redis single cluster thing, like it cannot do the geo-replication. Therefore, I cannot actually meet the requirements you expected it to be in the other side. So it's things like that where it actually bites, like it goes south, right? When most people just focus on, oh, here's the specification. But where actually the disagreements start and where every specific option toggle starts for every single provider is that, well, the capability or the guarantees behind it are not the same. And this is where you start actually putting, custom parameters on flag to say, well, yeah, pass this one for this provider because, like, yeah, sure, they're going to try to make it the same. Or, yeah, I understand you call the same function, but in this given provider, does not behave the way you expected. So, yeah, sorry, like, I forgot about that. That is the most important thing when defining these specifications. And sadly, the WIT by itself will not tell you that.
I think if are you saying the WIT as it is today would not tell you that, or because I wonder if we could get there, and the trick would be naming basically different worlds, and each world defining the behavior profile of the capability.
Well, you can, but like this is exactly why why I wrote the blog was like that page is like steering the conversation from the noun, which is KV, Jetstream, or stream, or whatever. It's like I understand that's too vague, right? Because we cannot just stop in the publish and pool, right? Or open pool. Like fine, that's fine. What are the actual capabilities I expected, right? For example, to make a point, right? A lot of people use RabbitMQ. This is not true anymore because RabbitMQ and Kafka, both of them now implement the exact same set of capabilities. But it used to be that, okay, if you want a queue, you use RabbitMQ. If you want a log, you use Kafka, right? And in production, for example, most people say, oh, I just need it pops up. And then they don't realize that if you have a log offset commit in Kafka, now how you actually NAC messages, because sometimes you have poison messages, yada, yada. So from the producer side of it, it's like, yes, but what about the consumer and the like what the expectations are from your perspective, right? Again, this is not true anymore because they both implement the stream. Kafka implement the queues, and now RabbitMQ implement the stream, right? But this is where most people start misunderstanding. For example, now NATS support batch publishing, right? That before would not be the case, right? So you have to understand that in your end and deal with the consequences. But also, what does that mean? Because NATS have a limit of 1,000 messages. Would that be something that you're going to run into, right? I'm not saying you will, but like these are the type of things that ideally and a specification would allow you to tell you, whatever that means. I don't know the answer, right? Because neither product buffer or WIT by itself today is clear on that.
Yeah. Well, I mean, I think definitely this takes a good first step towards it, right? Because we're very explicit, like, oh no, this is Jetstream semantics. Like, we do exactly what Jetstream does here. I think this definitely solves part of the concern. I think we're looking for a little bit more granularity, and then potentially having different worlds for defining the different behaviors of what you've configured for this.
Yep.
Jordis, if you're interested, you also have a lot of expertise in this. If you would be game to go and like add, any other ideas that you have for this on the issue that Aditya has proposed, that would be really helpful.
Okay. Yeah. No problem about it. I can leave some comments there. Yeah. It's so.
Cool.
Yep.
Thank you.
Thank you, Jordis. Can we just agree on leaving out the admin part of the NATS, creating buckets, because we can leave that up to the infra.
Certainly.
Part. Yeah. Okay.
Yeah. And honestly, I would recommend as you implement this, try to just do as one piece at a time. It's good to do the design like as a composite of what all these might look like, but then just keep it to exactly what you need. That's always the best principle, because then you can take it with what you actually are using on the other end and start integrating and getting feedback early.
Noted.
Yeah, and I was gonna add to what Joris just mentioned. I mean, having the non-functional requirements is key, because it's easy to implement the interface, but then the behavior is really, it's key in terms of what you expect, especially in failure modes. And that's the difference between a POC and a product. Then you can say, okay, what I'm expecting, what I do in terms of failures, what are the guarantees that I need support.
Yeah. Well, and I think non-functional requirements, specifically for this one, Aditya, make heavy use of WIT documentation. So, for example, we have this behavior challenge inside WebAssembly itself in WASI. Implementing things on Windows is hard. I think that's like a fair statement to make. And trying to describe how that would work, how somebody would implement it specifically in like WASI file system is a good place where you can see where we've iterated a few times on it, and just kind of expanding out the doc. I think if I open up like the blame here, you can kind of see an example where we've just continued to tighten that language. especially around error conditions. What Frank just said around error conditions immediately made me want to like pull that part up. And so just having this be part of the spec is incredibly valuable. Yeah. Okay.
I'm pretty sure I understood around 80% of that, but I'll take a look at this video again and
Cool.
just keep revising to it. And
Thank you.
hopefully I have something next week.
Well, 80% is much more than
That's pretty good.
exactly.
Yeah, and of course, keep asking questions, Aditya. And also, feel free to ever like throw agenda items on here. You know, sometimes I feel like I gotta like make content, and then now I'm looking at the clock, and we're like, 30 minutes over. I would much rather prioritize your stuff as you're actively working.
For sure, for sure. Yeah, really sorry about today's extended time, but yeah, I will
This
keep
is
that in
awesome.
mind next time. Okay.
Yeah. Cool. All right. Well, this was awesome. This was a really good one. For everybody that stayed extra for an extra 30 minutes, thank you. But I think it was totally worth it. That was a good conversation.